It's Wednesday. We got 2 weeks to fall break. Okay. Sounds good? Yeah. All right, so just to make sure, just to reiterate, we have an exam on next Wednesday, week from today. Today we'll start the last new section we're going to talk about before that exam. And we'll finish up on Friday. We'll also do a quiz on Friday. The quiz will be over 14.4, which was adding and subtracting rational expressions, and 14.5, which was the complex fraction stuff that we talked about last time. Okay. So that'll be the quiz. So the stuff we're talking about today won't be on the quiz, but 14.4 and 14.5 will be. Okay. Well, just like usual, we'll do that at the end of class on Friday. Basically, make sure we have a check on, make sure where you are with that material. And then we'll have a review on Monday, and then exam will be on Wednesday. All right. So let's go ahead and get started then, unless you've got questions about anything before we get started. Are things going okay? Yeah? All right, so let's go ahead and get started on our last new section. This is section 14.6, which talks about solving equations that have rational expressions in them. So rather than going through some long-winded explanation of what we need to do, let's just go through the different steps that might be involved in solving these particular types of equations. So this first one on this note sheet has this particular equation where we've got x plus 1 over x plus 2 plus 5 over 3x minus 1 equals x plus 4 over x plus 2. Most people aren't very excited about working with fractions. So the first thing we're going to want to do is get rid of the fractions. That's going to be our first step, is to try to get rid of those fractions. The idea behind getting rid of those fractions will be the same kinds of stuff we've been doing with finding least common multiples, find that least common denominator idea, okay? So one of the first things that you may need to do, and that's what it's talking about with this step 1 here, one of the first things that you may need to do is factor denominators. Just like what we did in the last 2 sections when we needed to get common denominators, we factored. Same idea, right? Well, in this example, there's not any real factoring to do because I've got an x plus 2 and a 3x minus 1, right? So there's not much to do in the way of factoring. Now, we do need to identify what we need to do to both sides in order to get rid of the fractions. So rather than doing it with variables to start with, let's say you had something like, maybe you had x over 2 plus 3x plus 1 over 3 equals x minus 5 over 2. Say you had something like this. Okay? Let's do it without numbers, or without letters to start with in the denominator. If I want to get rid of the 2's in the denominator, what can I do to both sides of the equation to get rid of the 2's? How do you undo division by 2? What do? Multiply by 2, right? I could multiply both sides by 2 and get rid of the 2's. Well, what I could do to get rid of the 3? Multiply by 3, right? So your first step here to get rid of those fractions might be to take both sides and multiply by a 2 and multiply by a 3. The 2, multiplying both sides by 2 gets rid of the 2's, but it doesn't get rid of the 3, right? Multiplying by a 2 is not going to get rid of the 3 in the denominator, is it? No. Well, and also then we'll multiply by 3 to help get rid of that 3. So notice in this case, we would multiply both sides by 6, if you will, because that's the least common denominator. Okay? Then we can distribute. We can distribute this here and this here. to each term. We're just doing distribution there. Because now what can you do? Oh, in this first term, what can you do with the 2's? Cancel them out, right? In the second term, what can you do? Cancel out the 3's, and on the right-hand side of the equation, you can. Over here on this side, we can cancel out the 2's again, right? And the 2's go away. And we're left with 3x here, right? Because the 2's went away. We're left with 2 times 3x plus 1. And on the right-hand side, 3 times x minus 5. And now the fractions went away, right? Okay? And then we can go through, distribute your 2, distribute your 3, collect your x's, and all that good stuff. Okay, I'm going to stop here because we'll do some other problems. But notice that the idea was I had a 2 in the denominator, so I multiplied both sides by 2 to get rid of the 2 in the denominator, right? I had a 3 in this denominator, so I multiplied both sides by 3 to get rid of that denominator. That was how we started the problem. Okay? So let's shift it over from numbers to variables. Okay? So in step 1 here, all this is asking you to do for step 1 is identify what we need to multiply both sides by. Okay? Well, what things do you see in the denominator? X plus 2 and 3x minus 1. So what do you think you want to multiply both sides by?
3x minus 1.
Yep. And x plus 2. Just like we did with the 2 and the 3, right? Whatever factor you see in any denominator, you want to multiply both sides by it. Okay? Does that make sense? Okay. All right, the second step is important for a check at the end. Okay, so it's asking you to identify any restrictions. Remember, restrictions are numbers that you cannot plug in for x. In particular, what makes a 0 in the denominator. Okay? So if I look at the first number, or the first denominator here, what makes this equal to 0? -2, right? Okay? What makes this one equal to 0? And if you need to set it equal to 0 and solve, that's okay. What makes this one equal to 0? 1/3, right? So those are your restrictions. So the way we typically write that, x cannot be -2 or 1/3. All this is doing is that if at the end you get an answer of -2 or 1/3, you would throw them out. Okay? Because we know that we cannot plug those into the original equation. So this is just lists. These are lists of bad numbers that the solutions can't be. Okay? It's just a check that we have to do at the end. All right. So next step here. Once we've identified the least common denominator, identified the restrictions, let's clear our fractions. Let's do what we said we're going to do. We'll take 3x minus 1 times x plus 2 times the left-hand side. And take 3x minus 1 times x plus 2 times the right-hand side. So again, the whole reason why we're doing that, we see x plus 2 in the denominator, so we'll multiply both sides by x plus 2 so that we can get rid of it. We see 3x minus 1 in the denominator, we multiply both sides by it to get rid of it. Okay? Our first step in all of these is to try to make it not have fractions anymore. Okay? Make the fractions go away. Now be careful. This is a plus sign in the middle here, right? Yeah. So right now I cannot cancel these x plus 2's. And I need to distribute first and then cancel. Okay? Remember, we can't cancel in individual term pieces, right? Distribute first and then cancel. Okay? So we would have 3x minus 1 times x plus 2 times x plus 1 over x plus 2 plus 3x minus 1 times x plus 2 times 5 over 3x minus 1. Distribute it to each term first. Okay? That product times that fraction, that product times the second fraction. Okay? Always, if you've got a plus or a minus sign in the middle, always distribute it before you try to start doing any canceling. Just so you don't get goofed up. Looking at this first product now, this first big chunk, what can you cancel? The x plus 2, those whole chunk, right? The x plus 2's go away. What about in the second chunk? The 3x minus 1. And then on the right-hand side, x plus 2's. So just cleaning up now. We have 3x minus 1 times x plus 1 left in the first part. We've got 5 times x plus 2 in the second part. And we've got 3x minus 1 times x plus 4 in the third part on the other side of the equation. So now notice fractions are gone, right? So now at this point, we need to multiply everything out and solve for x. Okay? Do all our distributions. So what do you get when you multiply out this first product here, the 3x minus 1 times x plus 1? What do you get? Okay. All right. Do all your distributions right. 3x times x gives you the 3x squared. 3x times 1 gives you 3x. Minus 1 times x is minus x. Minus 1 times 1 is negative 1. What do you get when you do the next distribution? Good. 5x plus 10. How about on the right-hand side? What do you get when you multiply out the right-hand side? Okay. Everybody okay with getting it all multiplied out? Yeah. Okay. Let's simplify a little bit, make it a little bit prettier before we actually start solving. What can you combine on the left-hand side? What can you put together? So yeah, the 3x, the 5x, and the x, right? 3x minus x gives you 2x plus the 5x gives you 7x. What else can you combine on the left-hand side? Plus 9, good. Yeah, minus 1 and the plus 10 can get combined and get plus 9. What about the right-hand side? We have 3x squared. Good. Plus 11x minus 4. That okay? So far, so good? We're just cleaning things up. All right. Notice now I've got a 3x squared on the left-hand side and a 3x squared on the right-hand side. So if you subtract 3x squared from both sides, what happens with those? They cancel each other out, don't they? If we do minus 3x squared on both sides, they just go away. So you get 7x plus 9 equals 11x minus 4. So now if we want to solve for x, what do we need to do? Yeah, get all the x's on one side, right? And get the constants on the other, right? It doesn't matter. It doesn't matter which way you go as long as you keep track of your signs correctly. That's exactly right. Yep. So let's say I subtract 11x from both sides and subtract 9 from both sides. We'll get negative 4x equals negative 13. Right, because we'll get 7x minus 11x gives us negative 4x. And negative 4 minus 9 gives us negative 13. What do we do for our last step here? Divide by negative 4. And get x equals 13 over 4. Say again? Yeah, we can just leave it as an improper fraction. That's fine. Now, the last thing you want to do is make sure that this is not one of the restricted values. Is that equal to either of the restricted values we found? No. So this would be our final answer then. So this is the process that we want to follow when we solve these. Is okay? See if you can do number 2. We'll do number 1 together here in a minute. But see if you can do the second one there. And then we'll chat about it. And then we'll do the first one together. Then you'll multiply that one. Yeah, it's multiply that one. Yeah. Ready to chat about it? Yeah. Okay, so looking at number 2 here, do we need to factor any of the denominators at all? Or are they okay to go? Anything to factor in the denominators? No. Okay. Good. Let's identify the restrictions. What numbers can you not plug in for x? What are bad numbers? Yeah, can't plug 6 into this one, right? Because that'll make that 0. And can't plug in -2 into this one. Okay. Remember, again, we're identifying the restrictions because that'll help us see. Whoops, I did that backwards. That'll help us see if the answer we get is one of those restrictions. That should be a -2. I'm going to erase that so it's a little bit better. Okay. Looking at the denominators now, what do we need to multiply both sides by? Good. Yeah. We have an x minus 6 in that first fraction, so we want to multiply both sides by x minus 6. What else? Okay, we get x plus 2 as well, because that's in the second fraction, right? So far, so good? Yeah. Okay. Then what do we do next? In particular, what do we need to do on the left-hand side? Good. Yeah, we need to distribute it to each piece, right? So we have x minus 6, x plus 2 times 3 over x minus 6, x minus 6 times x plus 2 times 7 over x plus 2. Notice we're multiplying, so on the right-hand side, we just have 1 times that. Well, 1 times anything is just the anything, right? So not too worried about the 1 at all. All right, what happens on the left-hand side now? Good, the x minus 6 goes away in the first one and in the second one, right? So we're left with 3 times x plus 2 plus 7 times x minus 6 equals x minus 6 times x plus 2. We good to hear? What's next? Yeah, multiply it all out. Distribute everything. What do we get for that first one? Good. And the second one? Good. And then on the right-hand side? So we need to multiply that out too, right? What do we get there? Good. All right, so we need to do all the multiplications, right? We got to distribute everything. Let's combine some like terms and then figure out where we go next. What do you get on the left-hand side when you combine your like terms? You get a 10x and -36. On the right-hand side, we get x squared minus 4x minus 12. Okay. Now, the first example we did, we had the same x squared on both sides that they end up canceling out. Does this x squared cancel out with anything? No. So this is a quadratic equation, and we've solved those types of equations before, right? We got something that involves an x squared. What do we have to do when we have something that's an x squared and we want to solve the equation? Well, you're right. You're thinking about factoring, right? But before we factor, what do we have to do first? What do we have to have on one side for factoring to help us? 0, right? We got to move everything to one side, right? And get 0 on the other. So we'll subtract 10x over and add 36. So we get everything on the same side. So we get x squared minus 14x plus 24. And then factor. What does that factor as? Well, since we have x squared, we have to use x and an x, right? Yeah. Go ahead. Good. And so we need things that multiply to positive 24 but add to negative 14. 2 and 12 will work. We're going to use both negatives. So now what do we do with each of those? Set them equal to 0. And so we'll get x equals 2 or 12. Now, do they both work? Are they both okay? Yeah, good. Ooh, hey, crossed right through them. Okay. What questions do you have on that? Oh, it was a little longer. It required you to remember some other stuff, right? Okay. All right, let's do the first one together, and then I'll set you loose on some practice problems. Let's look at that first one. First one, the reason why I wanted you to do the second one first and then the first one, that first one was a little bit different, right? What looks different about the first one than compared to the other two? Yeah, we got that piece right there, don't we? That x squared minus 5x minus 24. What do you think we want to do with that before we do anything else? Factor it. How does it factor? Good. We got to multiply to negative 20. Ooh, it's not 8. Yeah, you said a 5, and I wrote 5, and I'm like, wait a minute. All right, so we need things that multiply to negative 24 and add to 5, right? So we'll use a plus 8 and a minus 3.
Isn't that supposed to be plus 3 minus 8?
It is supposed to be plus 2 and minus 8. Yep. Thank you. Makes the problem a lot easier to do it that way. Plus 3 and minus 8. Thank you. All right. Before we do anything else, let's identify the restrictions now that we've got it factored. What can you not plug in for x? Negative 3 and positive 8, right? So your restrictions on this one, negative 3 and positive 8. What's next? What do you think you want to multiply both sides by now that we have it factored? Good. That's why we're going to factor it, right? Because it helps us identify what we need to multiply by. Didn't leave myself a lot of room here. Why did we choose x plus 3 and x minus 8? Well, again, we're just looking at the factors, right? I see x plus 3 in this denominator, so I want to multiply by it. I see x minus 8 in that denominator, I want to multiply by it. And it takes care of all the rest of them too, doesn't it? Okay. What's next? Now that we multiply both sides, what do we do next? Yeah, we're gonna cross. Yeah, we're gonna cross out, but we need to do one more thing before we cross anything out, right? We need to on the left-hand side. Yeah, I gotta multiply it through, right? I gotta distribute it out, right? So we'll distribute the x plus 3 times x minus 8 to both pieces on the left. Now we can start canceling, start dividing things out. In the first part, what divides out? X plus 3 goes away. How about the second part, what goes away? Yeah, the whole thing goes away, right? And on the right-hand side, x minus 8's go away. Good. So we have x times x minus 8 plus an x equals 4 times x plus 3. What's next? Got to distribute, right? We need to multiply everything out. After we clear the denominators, we're going to distribute everything out. What do you get in that first part? Minus how many x's? 8, good. And then we still have the plus x. And on the right-hand side, we have... Good. What's next? Yeah, I'm going to bring it all to one side, right? So we'll want to subtract the 4x over and subtract the 12 over. What do you get after you do that? So you got x squared. How many x's do you have? So you got negative 12, minus 8, minus 4, plus 1. So how many x's are left? So minus 8 minus 4 is negative 12 plus 1 will give you negative 11x. Good. And then you have a minus 12. Next part is 2. Other way around, right? X minus 12x plus 1. So we need negative 11. And then we set each piece equal to 0. And so what are your two solutions then? -12 and negative 1. Are either of those the restricted values? No. So those will be our answers. So notice that we're still using the same principles that we've used before, right? We factor our denominators to help us identify what a common denominator is. Rather than combining, we're just clearing the denominators. Yes, no, sorry. Oh, no, you're fine. You're clearing the denominators by multiplying, right? But it's the same kind of premise that we've been doing. All right. So here's some practice problems. Work on these for a little bit. We'll work on some more of these on Friday as well. Holler at me if you got questions. Happy to answer questions always. like I said, we will do quiz over 14.4 and 14.5 on Friday. That was our adding and subtracting and doing complex fractions. It'll be one of each, right? It'll be one combining addition or subtraction, and the other will be simplifying a complex fraction.